जैसे ही आपने ये फोर्स लगाना शुरू किया, immediately after that the center of mass of this stick has an upward acceleration of A, but that value of A is less than G. This is given in the question. हमारे इस चैनल पर आप सभी बच्चों का एक बार फिर से स्वागत है। आज के इस सेशन में हम जनरल रोटेशनल मोशन के ऊपर एक क्वेश्चन करेंगे। इस चैनल पर मैं लगातार आपको जेईई एडवांस लेवल के क्वेश्चंस के थ्रू फिजिक्स के टिप्स, ट्रिक्स और कॉन्सेप्ट्स बता रहा हूँ। आज रोटेशनल मोशन के इस क्वेश्चन को ठीक से समझिएगा। क्वेश्चन क्या है देखते हैं। अ यूनिफॉर्म स्टिक, एक्चुअली डायग्राम में इट इज लुकिंग लाइक ए ब्लॉक, it is actually a stick. I'll just redraw it. It is a stick, that means it is very thin, right? Its thickness is negligible. It is a stick that is kept on a horizontal surface. This is a horizontal surface. Mass of the stick is m, right? And now at the right end of the stick, a rope is tied and you start pulling it vertically up by applying a force F. Right end of the string, right end of the rod, the stick is being pulled up. There is a stick lying like this, and this end is tied to a rope, a string, and you start pulling it up by applying a force F. The question says that when you pull it up, it produces an acceleration A in the center of mass, which is less than G. Read the question properly. If you are pulling this end of the stick up, this force produces an instantaneous acceleration A in the center of mass. जैसे ही आपने ये फोर्स लगाना शुरू किया, immediately after that the center of mass of this stick has an upward acceleration of A, but that value of A is less than G. This is given in the question. So of course, as soon as you apply a force at this end in upward direction, the whole stick loses contact with the surface except this leftmost point. ये point सिर्फ ground के contact में रहेगा, rest everything will lose contact with the ground. So this end is in contact with the ground, and of course there is a normal reaction force acting over here. Now the question is asking you about guess about the value of normal reaction force. Will this normal reaction be equal to mg? Will it be greater than mg, less than mg, or will it be somewhere between mg by 2 and mg, or will it be exactly equal to mg by 2, so on and so forth. So these are the options, and you have to tell what will be the value of normal reaction. That means what is true for normal reaction among these four options immediately after this force is applied. Immediately after the force is applied, where do you see the value of normal reaction to be? That is the question. Students, give it a genuine try. Pause the video. I am starting my solution. The first thing that we need to understand is, this is a rigid body, okay, and there are various forces acting on this body. One is F, the other is mg, and the other is the normal reaction force acting at this end A. Let me call this end as A. As I have already explained that as soon as you apply this force over here, the whole stick will leave contact with the ground, only this end will remain in contact with the ground. So the normal reaction force obviously is acting at the leftmost end point A. So these are three forces acting on this stick. Now the acceleration of center of mass can be written as F plus n minus mg is equal to ma. Students, please understand, when you use Newton's second law of motion, F is equal to ma, F stands for vector sum of all the external forces acting on the body, and A stands for acceleration of center of mass of the body. When you are using the equation F is equal to ma, A is the acceleration of center of mass, that is one thing, and the second important thing is, while using this equation, we need not worry about the point of application of the force. मैं ये कहना चाहता हूँ कि अगर मान लो n की वैल्यू नहीं बदली, वही है जो अभी है, और F की पोजीशन को हमने यहाँ शिफ्ट कर दिया होता, तो क्या ये फोर्सेस अगर इतने ही रहते, पोजीशन चेंज कर दें सिर्फ हम, तो क्या सेंटर ऑफ मास का एक्सेलरेशन बदलेगा? नहीं, सेंटर ऑफ मास के एक्सेलरेशन को फोर्स किस पॉइंट पे लग रहा है इससे कोई लेना देना नहीं है. टोटल फोर्स क्या है, दैट डिवाइडेड बाय मास इज द एक्सेलरेशन ऑफ सेंटर ऑफ मास. अदर पॉइंट्स मे हैव डिफरेंट एक्सेलरेशंस, but the acceleration of center of mass is something that is decided by external forces, right? That is a very important concept that you must understand. Now, if you apply this force F, what is happening? The stick begins to basically rotate about this point A. Let us say its instantaneous angular acceleration is alpha. The whole thing starts rotating about this end point like this. The whole thing has an angular acceleration alpha, let us assume that. So, this is the rotation axis right now, right. So, what is the net force acting on this body? We all understand that normal reaction force will not produce any torque about point A. F will produce a torque, a counterclockwise torque, and mg will produce a clockwise torque. So, the net torque will be torque due to F minus torque due to mg. So, I am writing here the torque due to F is F into L, where L is this length. This is the rotation axis, my pen, this is the rotation axis. From this axis, the force, line of action of the force is at a distance L. Therefore, torque produced by this force about point A is F into L. Now, what is torque due to mg? It is mg into L by 2. Reason being, line of action of this force is at a distance of L by 2 from point A, and because the two torques are in opposite direction, we will take the difference. Net torque on the body about point A is this much, and this will be equal to I alpha. What is I? You must write moment of inertia of the body about the rotation axis, this axis, pen is the axis. What is moment of inertia of this rod about this axis? ml square by 3. So, ml square by 3 into angular acceleration alpha. Now, one more critical thing, one more very important thing. We can picturize this rod, we can think about this rod as if it is rotating about this point with angular acceleration alpha. Because the question is saying tell the value of normal reaction immediately after this force is applied, immediately after the rod begins to rotate. So, none of these points in the rod are having any speed right now. The force has just been applied. So, none of the points in the rod have any kind of speed right now. Okay. So, all these points are going in a circle, they are rotating about point A, but none of these points have any speed. So, when there is no speed, there is no centripetal acceleration. It is something like you are participating in a bike race and the racing track is circular. You are here with your bike and the referee says 1, 2, 3, go. So, immediately after he says go, what is your acceleration? What is your speed? No speed, no speed. So, because you are not having any speed, you are going to move in a circle, but right now you are not having any speed. Therefore, there is no centripetal acceleration, there is no radial acceleration. But your speed begins to change. As soon as you hear go, you raise the accelerator and the bike races ahead. So, there is an angular acceleration, there is a tangential acceleration, there is an acceleration in the direction of tangent, and the tangential acceleration is related to angular acceleration by what relation? Tangential acceleration is actually r into alpha, where r is the radius of this circle. This is true for any point. So, when there is no centripetal acceleration, there is only tangential acceleration, value of that acceleration will be r alpha. So, what about the center of mass right now? The center of mass is a point at a distance of L by 2, r is L by 2. The center of mass is going to move in a circle of radius L by 2. It is not having any speed right now, so there is no centripetal acceleration, but there will be a tangential acceleration, and this is the acceleration of center of mass. It will be alpha into r, r means L by 2. So, in terms of alpha, the acceleration of center of mass will be alpha into L by 2. So, in the first equation, A is the acceleration of center of mass, and in second equation, L alpha can be written as 2 times the acceleration of center of mass. We can write L alpha as 2a. So, making this change, let me cancel one L from here, right. just cancel one L, and you are left with one L here, L alpha, and L alpha can be written as 2A. So, this becomes 2MA by 3. Now, this is my second equation. Now, between these two equations, let us eliminate F. Let us eliminate F. Why do I want to eliminate F? Because in the question given here, there is no mention of F in all the 4 options. I have to find the value of n in terms of mg basically. There is no F involved here. So, I just want to get rid of F. Let us eliminate F. It is very simple. I will subtract equation 2 from equation 1. So, 1 minus 2, if I do 1 minus 2, this is minus F plus F cancels out. Here it is n, this is minus mg, this will be plus mg by 2. So, minus mg plus mg by 2 will be, sorry, it will be minus mg by 2 minus mg by 2. Do you understand what I am doing? I am subtracting equation 2 from 1. So, F minus F is 0, n is there, this minus this. So, this will become plus. So, minus mg by 2, this is equal to this minus this. So, this is Ma and 2/3 of Ma. So, this is 1/3 of Ma. So, from here I can see that normal reaction force is mg by 2 plus Ma by 3, right. Now, the question says that acceleration of center of mass is less than g. Therefore, this term is less than mg by 3. This term is less than mg by 3 and this is mg by 2. So, normal reaction is certainly greater than mg by 2. Normal reaction is certainly greater than mg by 2, but it is certainly less than mg. What is the value of normal reaction? mg by 2 plus ma by 3. But ma is actually less than mg. अगर ma mg के इक्वल होता तो ये mg प्लस आई एम सॉरी ये mg by 3 प्लस mg by 2 होता. अगर ma mg के बराबर होता, a g के बराबर होता, तो यहाँ पे हम लिखते हैं mg by 3 mg by 2, तो भी mg तक नहीं पहुँच पाते. So naturally this is less than mg, but it is certainly greater than mg by 2. So the correct option will be normal reaction is greater than mg by 2 but less than mg. So the right answer is B. I hope you have understood this. Many a times IIT wale do ask such type of questions in which you have to decide a range, and if options are like this, it might be perplexing. So watch this video again if you have not understood this. Make sure that you understand this question. Bye bye. See you in the next video.